the bizarre tale of the tongue-eating louse, nature's most macabre parasite. In 1995, marine biologists working off the coast of California made a discovery that would both horrify and fascinate the scientific community: the tongue-eating louse, Cymothoa exigua. This parasitic isopod would come to be known as one of nature's most bizarre and disturbing organisms. The tongue-eating louse begins its life in the ocean as a free-swimming larva. It seeks out a suitable host fish, typically species such as the rose snapper or other members of the Lutjanidae family. Upon finding a host, the louse attaches itself to the fish's gills, where it can safely grow and develop. This initial stage of its life cycle is relatively common among parasitic isopods, which often use gills as a site for feeding and growth. As the louse matures, it undergoes a remarkable transformation. The female louse makes its way into the fish's mouth, anchoring itself to the base of the tongue with powerful, hook-like claws. Here, it begins its gruesome work. The louse severs the blood vessels in the fish's tongue, causing the organ to atrophy and eventually fall off. Once the tongue is gone, the louse attaches itself to the remaining stub, effectively replacing the fish's tongue with its own body. Rather than killing its host, the louse coexists with the fish, performing many of the same functions that the original tongue did. The fish can continue to eat and survive, albeit with a parasitic passenger in its mouth. The louse feeds on the fish's blood and mucus, deriving all the nutrients it needs without causing immediate harm to its host. This unusual symbiotic relationship allows the louse to thrive while keeping its host alive. The discovery of the tongue-eating louse was met with a mixture of shock and fascination. Marine biologists and parasitologists were intrigued by the louse's unique adaptation and its implications for our understanding of parasitism. Unlike many parasites that weaken or kill their hosts, Cymothoa exigua's strategy ensures the long-term survival of both the parasite and the host. This balance between parasitism and symbiosis highlights the incredible diversity of life strategies in the animal kingdom. Further research into Cymothoa exigua revealed more about its life cycle and behavior. Scientists discovered that the louse's reproductive strategy is as unusual as its feeding habits. The louse starts life as a male, but as it matures and finds a suitable host, it can transform into a female. This ability to change sex is known as sequential hermaphroditism and is relatively rare among animals. The presence of multiple lice in a single fish's mouth can lead to a hierarchical arrangement, with the largest individual becoming female and the smaller ones remaining male. The tongue-eating louse's impact on its host fish is significant, but not necessarily lethal. Fish infected with the louse can still feed and grow, although they may experience some reduction in feeding efficiency. The louse's presence in the fish's mouth can also affect the fish's behavior and overall health, making them more susceptible to predation and other environmental stresses. Despite these challenges, many fish manage to survive with their parasitic companion for extended periods. The discovery of the tongue-eating louse also raised questions about its distribution and ecological role. Researchers began to investigate whether similar parasitic isopods existed in other parts of the world and how these organisms fit into marine ecosystems. They found that Cymothoa exigua and related species are widespread, occurring in various marine environments from the Pacific to the Atlantic. These parasites play a role in regulating fish populations and maintaining ecological balance, much like predators and other natural regulators. Public interest in the tongue-eating louse was piqued by its shocking and macabre nature. Media outlets and documentaries showcased the louse, often sensationalizing its gruesome feeding habits and highlighting its bizarre appearance. This attention brought the world of parasitology into the public eye, encouraging people to learn more about the hidden complexities of marine life. Educational programs and exhibits featuring the louse became popular, drawing curious visitors eager to see this unusual creature up close. In addition to its biological and ecological significance, The tongue-eating louse also became a symbol of the incredible diversity and adaptability of life on Earth. It serves as a reminder that even the most grotesque and seemingly unnatural organisms have evolved to fill specific niches in their environments. The louse's unique adaptation is a testament to the power of natural selection and the endless possibilities for survival strategies in the natural world. The discovery of Cymothoa exigua also had practical implications for fisheries and marine conservation. Understanding the impact of parasitic isopods on fish populations helped researchers develop better management practices for commercial fisheries. By monitoring and controlling louse infestations, fisheries could improve the health and sustainability of their fish stocks. This research also contributed to broader efforts to protect marine ecosystems and maintain biodiversity